Okay, today we will start a new chapter. The name of the chapter is Design of Column Bases. In general, what happens? The loads from the slab comes to the column, and then column to foundation, then foundation to the soil below the foundations. And we know that column is a compression member. So compressive load comes in column, and then column to the concrete block of foundation. Concrete block. That means the compressive load transferred to the concrete block, or column is placed over the concrete block. But when large or huge amount of load comes, or compressive load on the column, and that is transferred through concrete blocks, in that cases when the concrete block is insufficient to take that amount of loads or to resist. In that case, what happens? When huge amount of load comes on concrete block, then and that amount of load is unable to take the concrete block. In that case, we will provide a steel block, a steel base plate, basically steel base plate over the concrete block. First, we provide concrete block, and then we place a steel plate, that is called base plate, and over the base plate we provide the concrete block in order to resist, in order to safely transfer the loads to the concrete block. As we provide the base plate, and the area of the base plate is larger than column section, so stress will be reduced due to same load. Okay. The concept of column base design will be more clear if we draw the plan and top view, plan and section of the column base. So let's draw a column base. Everyone, draw this diagram. First, what happens? Basically, this is the front view of a slab base. First, there is a column I section will be subjected to vertical compressive load P. It is axial loaded. Basically, the column is axially loaded here. Though column is subjected to axially load as well as some moments only. So let's say moment is also in. So I am taking only the axially loaded column. Yes. Okay. The column is subjected to axially load P, and the column is support below the column base. There is a steel base plate, and the steel base plate is placed over the concrete block. Okay. And when we are designing the axially loaded column, we consider that the pressure distribution is uniform from the concrete below. As we know, the every action has equal and opposite reaction. So, concrete steel base plate is placed over the concrete block. So, an uniform pressure distribution will be there below the steel base plate. We consider that the pressure distribution is uniform. Assume pressure distribution. It is uniform. Pressure distribution uniform from concrete below. Okay. And generally, there are two types of column bases. First is your first type, when the column load transfer directly. First one, the column load transfer directly, and the second one, in case of second type of column bases, some sufficient or appreciable amount of moment is also transferred or considered with direct loads. That means, for case 1 type of column basis, only transfer the load directly. But in case of second type of column basis, some bending moment and the column is designed for column basis is designed for some bending moment with direct loads. Okay. So, but today we will discuss about the directly or only axially loaded column. Okay. So, and there are another two types of column base based on the base plate and gusset plate. Type 1, type 2 মধ্যেও আবার দুটো আলাদা টাইপের কলাম বেস আছে. First one is your slab base, second one is your gusset base. But generally, slab base is in your mainly important in your syllabus. Or slab base is included in your syllabus. Okay, slab base. Gusset base is not included in syllabus. Just you have to know a little bit about the gusset base. But slab base is more important here. And we will discuss about the slab base. What happens actually? The load first transferred from column to base plate, then base plate to concrete block, then concrete block to the beneath soil. So I am talking about the design of column base. This is nothing but column base. So design means what kind of design? Design means what will be the area of this base plate and the size of the base plate, and as well as the thickness. Area and thickness, we have to calculate the size of base plate as well as the thickness of base plate. Okay. Now we have to provide two cleat angles to hold the column in position. Though the load is directly transferred to the base plate and then to the concrete block, but to keep the column in position or to maintain the verticality of the column, we have to provide minimum 2 number of anchor bolts and 2 cleat angles to hold the column in its proper position. Here is a 2 cleat angle. These are nothing but 2 cleat angle. Okay. and there are two anchor bolts. These are called anchor bolts. Anchor bolts, and this is called your pleat angle. So question will be there, why we provide anchor bolt as well as pleat angle. That means to maintain or to hold the column in position and to maintain the verticality of the column, we provide anchor bolts and minimum 2 number of bolts when the load is transferring directly, okay, or by perfect bearing. Now, if I draw the top view of the column, then how it look like? Top view. Okay, let's draw the top view of the column. Column is I think let's erase this portion. Now let's draw the front top view, a plan. This portion is your concrete portion. In plan, a top view, you will see this portion, all this portion. This portion is your concrete. And this portion is nothing but what? This portion is your concrete base plate. Only this part. You will see from the top, vertically from the top. Then this part is your concrete base plate. Okay. And there will be the I section. You will see I section that will be projected here. Let's draw the I section. Isn't it? I section, this portion, and then there will be a pleat angle as well as pleat angle, shorter leg, longer leg. So it will look like this. Two anchor bolt will also be there. Anchor bolt, these are this. Before that, this will also is it. these are nothing but anchor bolts, and this portion is your rectangular scale কোন পার্টটা thickness of flange or thickness of wave whatever rectangular এই সাউন্ড লেগের উইথটা তাই তো rectangle আছে আর সেকশনটা আছে বেসিক্যালি এই গেল আমাদের টপ ফিগার প্ল্যান। তাহলে যে আমরা যে বেস প্লেটটা ড্র করেছি দিস ইজ ইওর বেস প্লেট, দিস পার্ট ইজ ইওর বেস প্লেট তাই তো this is your base plate, and this part is your concrete block, this part is concrete block, is it clearly visible? Concrete block. So we have to design the base plate, that means we have to calculate the size of the base plate as well as the thickness of the base plate. Okay, let us provide a square base plate having its size A into B. That means your this length is nothing but your suppose this length is nothing but your L, let us say, and this length is nothing but your capital B, L into B. So we are providing a base plate size B into L. Okay. Now this value is called what is called this value? This is the depth of the overall depth of the section which are used as a column. Overall depth of the section. Overall depth, let us say capital D. Let us say projection of the base plate beyond the column fixed, column H. This is the column H. This is column H, nothing but this column H. So let us say B is the projection of the slab base plate from the edge of column along L. Similarly, projection of the base plate along B is your small a. Clear? We have to calculate the size and thickness of the base plate. Okay. Now I am discussing about basically the slab base design. When the column is subjected to axially loaded. Okay. Not there is no moments, only axially loaded. And the pressure distribution I am considering pressure distribution below the base plate is uniform. This is the assumption. While we are designing the slab base with direct or axially compressive loads, we assume that the pressure distribution from the concrete block is uniform on the base plate. Now let's discuss about the design procedure of slab base. Design procedure of slab base. Step 1. Provided grade of concrete greater there have been uniting that. Design procedure of slab base. Step 1. First you have to calculate the bearing strength of the concrete. This is the concrete block. We have to calculate the bearing strength of the concrete. write down calculation of bearing strength of concrete. Sigma B is equal to P by Sigma B is equal to 0.45 FCK. It is given in IS 600. If the characteristic compression strength of concrete is FCK, suppose M20 concrete. Then its FCK will be how much? 20 ampere. So we can calculate easily 0.45 into 20. So first calculate the bearing strength of concrete. As per IS code, sigma bearing is equal to 0.45 FCK. That means this amount of sigma B amount of stress will be resisted successfully by this concrete block. Clear? Then you have to calculate. Now this base plate is provided just above the concrete block. So, and load, factor load in column is given. Then step 2. Calculation of area of base plate. Calculation of area of base plate. A is equal to A required, means how much area is required to resist the column load. A required is equal to your P divided by sigma B, where P is factor load in column. Factor load in column. Factor load means W. W is the suppose point load, point compression load. Suppose P is your just working load. Then factor load will be how much? 1.5 into P. Very simple. P is factor load. So area required, because the amount of load which comes from column to base plate in respect to concrete block. So if the area is capital A required area capital A is equal to your load divided by bearing pressure of concrete. That is nothing but the area required to resist that load. So area required, or A required, is equal to P factor load by bearing stress, bearing strength of concrete. Then step 3. Size of base plate. Suppose from this equation you can calculate how much area is required for the base plate. So you can provide rectangular size base plate or maybe square size base plate. Okay. In our first consideration, we provide square base plate. So let us provide a square base plate. Then A is equal to B is equal to how much? Root over of A, nothing but A square is equal to area. So A is equal to B is equal to root over of A. Very simple. Again, we have to calculate, we are putting A, B into A. But where we place the column, up to how much distance from this edge we can provide the column section. Up to how much distance from this side we can provide the column section. So for that we have to calculate A and B. That means projection. This is called larger projection is a smaller projection B. So for that, this is your nothing but your how much? PF. PF stands for so we have to calculate the projection A and B. So this amount is nothing but your how much? PF. PF means what is PF? This is called BF. BF. This is called BF. Upon what is called BF? Bottom plate. No, not like that. BF is without flange. Without flange. This is your without BF, without flange. So we can write A is equal to B plus B plus B. Okay. So A is equal to now A into B saman A. Isn't it? Area is square side, so A into B saman overall area of the base plate. So A is equal to B plus 2B and B is equal to how much? BA plus A plus A. This amount is A. Similarly, this amount is also A. So BA plus 2A. BA plus 2A is equal to your A. B plus 2B. BA plus 2A is equal to your A. Where A is, write down everyone. Now, here you have to calculate the value of A, B. What is called A? Write down everyone. A is bigger or larger projection. Write down A, larger or bigger projection. হচ্ছে না যখন কাজ করতে যাবে তখন এই শুরু করো A is the bigger projection from what again? From column edges. Column edges. All are in millimeter. Distance all are in millimeter. Bigger projection from column edges. Similarly, B is smaller projection from column. Okay. A and B are the side of the base plate. A is the bigger projection from the edge of the column and B is the smaller projection from the edge of the column. Now, to solve the problem easily, let us say P is equal to A. If B is equal to A, if both the projection is same, then only one unknown in this equation. Area will be calculated from here, some value. B and BF is given from the I square or I section property. Only B and A is unknown if B is equal to A. So this will be the equation of quadratic equation of A or B. So from this equation you can calculate A and B. Okay. So in this way you can calculate the size of the section as well as the projection, larger projection as well as smaller projections. Okay. So up to this is clear. Then next day. shall I erase the first two steps? Now then step number 4 or 5? Step number 4. Step number 4. So size we have already calculated. Then thickness. Calculation of thickness of base plate. TS. Go to clause number 7.4.3.1 problem. 7.4.3.1. That is a clause. Minimum thickness of the rectangular slab base is supporting column under axial compression. The thickness of the minimum thickness of the base plate given in clause number 7.3.1. 2.5. Before that, before that, there is one more step. Calculation of bearing stress or bearing pressure. Bearing pressure from concrete pedestal. Calculation of bearing pressure from concrete pedestal. Bearing pressure. How much bearing pressure comes from this concrete block? Bearing কথাটা কেটে দিলেই ভালো হয় bearing pressure. আপনাদের লাগবে প্রথমে দেখেছিলাম ফার্স্ট bearing আবার bearing calculation of pressure index. Calculation of pressure intensity. Calculation of pressure intensity from concrete pedestal. How much amount of pressure intensity will come from concrete pedestal? Load is constant. I am providing area A. Okay. Always try to provide amount of area required is less than is equal to area provided. যতটা এরিয়া আসবে তার থেকে একটু বেশি দেব, কম দেব না। ঠিক আছে? ধরো এরিয়া ক্যালকুলেশন এখান থেকে আসছিল 100 মিটার স্কয়ার। প্রোভাইড করতে হবে 110। সো এটা রিকোয়ার্ড প্রোভাইড এ প্রো 110। দ্যাট মিন্স যে রিকোয়ার্ড আসবে তার থেকে একটু বেশি দেব, কম দেব না। আমার সেভ দেখার জন্য। That's why check it out. W. Calculation of pressure intensity from the concrete pedestal is equal to factor load by area provided. E by A pro. Then step number 5. This value generally you see in the problem. You see in the problem. This should be sigma. Maximum capacity of the concrete intensity concrete is bearing strength sigma b. Always W should be less than is equal to sigma b. This will be clear if I solve the problem. Okay, now step 5. Calculation of thickness of base plate or slab base. Thickness of slab base. Slab base. Bracket TS. T thickness is given in IS code like 2.5 W square minus 0.3 square gamma m0 by something F for it. I think given IS code का करो देखो yes. Clause number 7.3.4.1. The minimum thickness of the slab base should be 2.5 W square minus 0.3 square gamma m0 by F1. There was understood. And this TS shall not be less than thickness of flange, or this value or TS should be greater than thickness of flange. যে ভ্যালুটা TS আসবে সেটা 7.431 sorry 7.4.3.1. From this formula we can calculate the minimum thickness of the slab base or base plate, and the minimum thickness of the base plate should be more than the thickness of flange of the section, I section or the column section. Always thickness of slab should be greater than thickness of flange. Clear? Suppose this is your 11, but this comes 10, then you have to take 11. If it's 12 and this is 11, then you have to take 12. Clear? Minimum value always should be thickness of slab base always should be greater than thickness of flange, or should not be less than thickness of flange. Value of thickness of slab should not be less than thickness of the flange. It is given in IS code also. So these are the steps. So from step 5 we can easily calculate the thickness of the slab base.